welcome back to our trigonometry lessons, and in this lesson we are going to draw the sine function and learn a little bit more about the sine graph. Now a sine graph is usually of the form y equals a sine x plus q. Now I'll start here from the y and explain these letters as I go to the right. So the y is basically our y values on our y-axis, right? Okay, so the vertical values. Now a y can also be written as fx or gx or hx or any letter with the x in brackets. It simply means the function of x is equal to. Now please don't get this wrong. Fx means exactly the same as y, and if you have fx equals 2, then that means that we are up 2 values on our y-axis. The fx means exactly the same as y. Okay. Now, then we go to the right and then we see the letter A. What is the letter A? The letter A tells us the amplitude of the graph, okay? And I'll explain that later, so I just want you to know that that A is the amplitude. Then we have the sine of x and then plus q. Now that plus or minus q, it will sometimes be a plus number or minus a certain number, okay? Now this plus or minus q that you will sometimes see means that the graph goes up or down. If it's a plus q or a plus 2 or a plus 3, it moves up 2 or 3 units. If it's a minus 1, it moves down 1 unit. Got it? Okay, so that constant that we add or subtract tells us whether we move the graph up or down. Now a sine function has two shapes. We have a positive sine function. See, that value of a is positive and there is a at the front. It can be seen as a 1, okay? So that is a positive 1. So from the point where we start on our graph, we first go up, make the turn, then go make a turn at the bottom and go up again. When we have a negative function, so a negative a here, a minus 1, right? From the point where we start, we go down first, then up and down again. Got it? So look at the two differences. What a positive sine function looks like and what a negative sine function looks like. Now, I'll explain these words as we go about, but this first one is quite important. The sine function has a period of 360 degrees. Now, what does it mean to have a period of 360 degrees? This basically means that it takes 360 degrees for an entire cycle to complete. So, it takes 360 for a sine graph to make these two turns. From 0 degrees to 360 degrees. Got it? Same with the negative one. From the point where it starts, which will be 0 degrees on our x-axis, it takes 360 degrees horizontally to complete itself. So, before I start with the minimum and maximum values and so on, I'm first going to draw in this positive function, y equals sine of x. Okay, now I'll show you later how to draw it later in this lesson, but a sine of x function basically looks like this. Got it? Okay, because it's a positive sine x, we start at 0 because a normal sine function which doesn't move up or down, see there's no plus a value here, no constant, no plus q, no plus nothing or minus nothing. So if there is no up or down movement in a sine graph, we always start at 0, okay, right here at the origin. Because it's positive value, the a, it's a positive 1, we go up first, then make the turn, and then go down, make the turn again, and up. So now that I have this graph, let's quickly look at what is the minimum value. The minimum value is the lowest point of the graph as read on the y-axis. Okay, now this is our graph. What is the lowest point? Right there, right? And how do I know what's that value? We go and find it on the y-axis. So it's minus 1. So for this graph, I can write here that the minimum value is a minus 1. Got it? Okay, then how do we find the maximum value? Well, it's the highest point of the graph as read on the y-axis. So we go to the highest point, that's the highest point, and then from the highest point we just go to the y-axis and go read the value, which is a 1. So basically there we go. So our minimum value is minus 1, our maximum value is 1. Then what is the amplitude? Now, I'll show you in two ways how to find the amplitude. The first way is when they give you the equation. Well, the amplitude is A. And what is A here? It is a positive 1. Okay, so basically the amplitude for this graph is 1. Now, what if we don't have the equation and we just have the graph and they ask us what is the amplitude? Well, the amplitude is the distance from the lowest point to the highest point divided by 2. Okay, so this is the lowest point and we need to go up so that we're in line with the highest point. So what is the distance? We go from -1 all the way to 1. So that's 2 units, right? 1, 2 units. And please, distance is always positive, so don't think about that minus at the front. It's just how far do we need to go from the lowest point to the highest point, which is 2 units. Then we take those 2 units and we divide it by 2 and we get an answer of 1. See, same as that one. So basically the amplitude tells us if we draw a horizontal line right through the middle of this graph, it means that it goes the amplitude amount of values up. So the amplitude is 1, so it will go 1 value up to its highest point and it will go 1 value down towards its lowest point. Got it? Okay. So it is also the value in front of the sine function, always expressed as a positive number. So even if there is a -1, the amplitude is still a 1, okay? Because it goes 1 unit up from the middle and 1 unit down from the middle. Okay, then we look at the range. The range is from which lowest y value to which highest y value does the graph go. Now it goes from -1 all the way up to 1. And we basically already have the minimum and maximum value, so this has to be written in a different way. So the range wants to know from what's the lowest point to what's the highest point. And look carefully how I write it. I'll do this here in red. We will simply say that y is an element of, and it goes all the way, and I use these brackets here, these closed ones, because the lowest point includes this -1. So basically it goes from -1 all the way to 1, and the highest point includes that 1. So basically we close the bracket like this as well. Got it? Okay, so the range really wants to know the range from the lowest point to the highest point. All these values from how low to how high. That's what the range is. The domain basically wants to know from which most left value to which most right value do we go. Okay, so how far left to how far right? That is what the domain asks. So from which lowest x value to which highest x value does the graph go? Well, the lowest x value is 0 and it continues all the way right until we get to 360. So how will we write this? Basically, we will just simply write here that x is an element of, and it starts at 0, it includes the 0, and it goes all the way to 360. So please look at how we write the domain, how we write the range, because it's not the same as the minimum, maximum, or the amplitude, or even the period. Because if I ask what is the period of the sine function, we always just write 360 degrees, okay? Because it takes 360 degrees for an entire sine graph to complete itself. So let me just quickly revise what it means when we talk about the range. How low to how high, right? And the domain, how far left to how far right. And this is the way we write it. Very important. This writing notation is so important. Now, let's continue with our graph here. So, we have drawn the sine x graph here, and I quickly want to show you what happens if we basically take this sine x and then we add 2 to it. So basically if we plus 2, then it means that this graph is going to move 2 places up. So look what happens to this point. It starts at 0, then it goes up 1, it goes up 2, and that is what it will look like now. Okay, got it? Let me just move it back. And then I'll scratch out this plus 2 and I'm going to leave it there. And then I'm just going to say here, what happens if we move it down 1? Okay, so now I'm going to take this graph and it's just going to move down 1 like this. And that is what it will look like. Okay, so understand, this values that we add or subtract moves the entire graph up, or it moves the entire graph down so many places. This was a -1, so it moved one place down. Okay, again, I'll just go back here, and then I'll also scratch out that -1, and then I also want to show you what happens if I put a minus at the front here, okay? So now we have a minus here at the front, which makes it a negative sign function. So basically, from the point where we start, we need to go down first, make the turn, and then make the turn and go down again, right? Okay, so keep your eyes on this graph for a second here. So this is what's going to happen. It's from the origin, it's just going to go down, make the turn, and up and down. Let me just move that correctly. There we go. And that is what a negative sine x graph will look like. And again, if we plus 2, it will just move 2 places up. If we -1, it will just move 1 place down, and then it will look like that. Okay, got it? I'll show you later how to draw it, because it is really, really easy. You might think it is hard, but you just have to remember these shapes, and I'll show you how to calculate it really, really easy and quickly. So let me put this graph back to where it's supposed to be, and I'm going to invert it again just to show you what it looks like if we change the amplitude. So this is what our normal sine x graph look like, right? The y equals sine x without the minus. I'll say again, without the minus. So look closely what happens if we change this function here to the following. Let's call it fx. So I'll call this one fx is equal to, and we make it 2 sine x. Okay, so now we change the amplitude. Look what happened to this graph now. Now it looks all of a sudden like this. Can you see? Now the amplitude is 2. So if from the middle of the graph, it goes 2 units up and it goes 2 units down. And if you want to find the amplitude, if you don't have the equation, basically we go all the way from -2 all the way up to 2, which is 4 units. Divided by 2 gives us the amplitude of 2. Got it? Okay, so the amplitude basically stretches this graph out to the top and stretches it out to the bottom if the amplitude increases. And if it becomes a half, it will just be smaller, right? Okay, so great. And what if we plus 2 here? It will just move this blue graph 2 places up. If we minus a 1, it will move this blue graph 1 place down like this. Got it? And that is all that you need to know. So great. So let's quickly go and see what these graphs look like when we have to draw them and answer some questions about them. Now we are going to learn how to draw a sine function. Now, drawing a sine function should not be hard. Okay, your calculator gives you the plotting points and the coordinates, and I'll show you how to do that. So remember the sine function shape. Okay, it has 2 shapes, one when our function is positive, one when our function is negative. Do you remember them? Okay, with a positive one, it looks like this. We have to go up and turn and up again, right? And when it is negative, we go down and turn and up and turn and down again, right? Okay, great. Now, make sure your y-axis and x-axis spacing are correct. Well, these spaces are equal and those spaces are equal. So important if you have to draw it. Sometimes they give you the graphing paper and then it's no problem. Now, we can use steps of 30 degrees, 45 degrees, 60 degrees, or 90 degrees. The smaller your steps, the more coordinate points you will have. Now, what does these steps mean? The steps basically means these steps on the horizontal axis, okay? So, in my case, I chose 90 because it's more than enough for this function. You could also go 60 degrees or 45 degrees or 30 degrees. Usually, we use multiples of 15, okay? But not 75 because usually if we don't plus or minus a value here, our turning points will be where the 90 degrees and the 270 degrees are. But the more coordinate points you want, the smaller you make these steps, okay? And I'm going to use a step of 90. So we want to draw fx equals 2 sine x. Okay, now here is my calculator, so please follow and I'll show you how this works. So from our calculator, I simply go and then I press the mode button, then I press 3, which access my table. Then it says fx, so I type in 2 sine alpha, press the alpha button and then the x button right there and close the bracket off and equal. Then it says gx if we have another graph, but I never use it, so I just press equal. Then let me just pause the video. Now if I go back a little bit, there we go. They asked here that what is the start? Now the start is where we want to start with our function. Now in grade 10 our functions usually start at 0. Okay, so when they ask us to start, your calculator immediately says 1, but what you do is you just simply go type 0 and then press equal. Then it asks me the end. Where do we want to end? Well, we want to end on 360 degrees. Got it? Unless they tell you here that you must draw it for until 720 or just 180. Okay, then it will be just half your graph. If they say 720, it will be 2 cycles, right? Okay, so the end is 360. And then once you type it in, your calculator already has a default 5, but then just press equal and then it reads in the 360. Now they ask you the step. Now I told you that the step can be 30, 60, 90, so multiples of 15 as well as 45. But I want to work with 90 today, so having 4 spaces is more than enough. And then I type in 90, press equal, and boom, there we have our complete table of our x and y values. So look what I just do, and I'm going to do it for the first 3 here and then I'll resume the calculator work. So our first value is x must be 0, and when x is 0, our fx or our y value is also 0. So where is our x 0? Right there. And where is y 0? Also there, right? So look what I do. I'll draw this in blue. So I'm going to make a blue dot right there, and that is my first coordinate point. Then our next one is 90 and 2. So I go to 90 degrees on my x and my y value is a 2. So it's all the way up to there. So I'm going to make my coordinate dot right there, which is in line with my 90 degrees on my x-axis and in line with my 2, which is on my y-axis. And then we have 180, so I go to 180 on my x-axis, and what does the y value say? 0. So I'm 180 on my x-axis and 0 on the y-axis, so I'm right there, and I'm going to plot the dot right there. There we go. And then we wait for this calculator to quickly scroll down. So down, down, and one more down, and again, and there we go. And I can pause because that's all the detail we want. So my x value is 270 and then my y is minus 2. So here's 270, go down until I'm at in line with the minus 2, so it will be right there. And then I make another blue dot right there, which is another coordinate point. And then I go to 360 and 0. Well, this is my 360. My 0 on my y-axis is right there on this line, so I can plot another point right there. So basically these are the coordinate points, and now I can quickly put away my calculator. And now here comes the part that I told you about. We must know the shape. This is a positive sine function, so from the starting point we're going to go up, turn, down, turn, and up, and make sure about your shape, and I'll do my best here. So we're going to go up, turn, and all the way down through that point, make another turn here and up to 360, and there we go. And we finished drawing our sine function. As easy as that, right? Okay, so it's not hard. So quickly tell me, what is the maximum value? Well, it's a 2. What's the minimum value? It's a minus 2. What is the range? Y is an element of minus 2 all the way to 2. And what is the domain? Well, it goes from 0 to 360, and we write it as x is an element of 0 to 360. Right? Okay, so that's quite easy. And it just takes a little bit of practice to get used to it. Now I'm going to throw in a little bit of extra here. So what if they ask, and I'll quickly write it here, what if they ask you the following, that you are only allowed to draw the graph for x is an element from 0 degrees to 180 degrees, okay? Then basically it means that you're only going to draw that part, and you are not going to draw anything from 180 to 360. So can you see that you're only going to draw this top part? Okay, and then we only have two values here on the x-axis. That's a little bit too little. So what we do is when we enter the step on our calculator, we basically want 4 values. So then we basically make it multiples of 45, or steps of 45. And I'll show you also later how that works. So let's go and try another 2 examples, and I'll show you the calculator work, and then you can re-practice these 3 because it's really easy to draw these graphs. Now here are 2 more examples that we are going to try and draw. Okay, so the first one is draw fx equals minus sine of x minus 1. Now to draw this function, I'm simply going to take my calculator and I'm going to open it up, and then I'll show you what to do. So here we go. We press there the mode button, press 3 to access the table, then we have fx, press minus sine, then alpha x, and please remember to close the bracket, and then you just simply press the minus 1. Press equal, don't worry about the gx, just simply press there, if they ask you gx, just press equal, then it will go away. Now they ask the start. Where is our domain starting? It starts from 0 and then it will end at 360, right? Okay, so let's see. And we type in 0 equal. The end is 360. Press the equal sign. Then they ask us the step, which we are going to make 90. And there we go. So basically, here are our table with the coordinates. So the first coordinate pair is 0 and minus 1. So x is 0, y is minus 1. X is 0, y is minus 1. So we simply go and we plot that point right there. There we go. And the second pair is 90 and minus 2. So where's 90? There it is. Then we go down to minus 2. And there we go. So that's 90 and minus 2. Then we go to 180 minus 1. That's 180, so we go up or down to go and find minus 1. We will go down to find minus 1, so it will be right there, and we make the dot there. Okay, so let's scroll down. Scroll, scroll, and another scroll, and another one. There we go. And basically there's the last 2 pairs of coordinates. So 270 on our x-axis, that's there. And we have to find 0. We're on the 0 for our y value, right there, right? Okay, so that is the point where it's 270 and 0. And then 360 and minus 1. There's 360 minus 1 will be right there. And that's the coordinate pair. There we go. Now we simply have to just draw the function in. It's a negative sign function, so it will go from the point where we start down first, turn, up, turn, and down again, right? So let's quickly draw that in and work carefully when you draw it. So we go down, it starts to turn, then it goes up, 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 and then it starts to turn through the 270, makes the turn, and to 360. And there is our sine function, as easy as that. So let me quickly put away this calculator, there it goes, and now we can answer the following questions. What's the period for this graph? Well, our period for a sine function is 360 degrees, so I will simply write here 360 degrees. What is our minimum value? That's the lowest value on our graph, which is right here, as read on our y-axis. So the lowest point here is a minus 2. So let me write that in, minus 2. What is our maximum value? That's the point up here, the highest point, and the y value is a 0, right? Don't forget, as read on our y-axis. So it is a 0. Our amplitude, well, it goes from minus 2 all the way up in line with the 0, okay? And minus 2 to 0 is 2 units divided by 2 is 1. So our amplitude is a 1. And you can also see it right here at the front, even though it's a -1, we throw away the minus and we just write the positive value of the amplitude always. Okay, so it's just a 1. The range, how low to how high? Well, it starts at -2, it goes all the way up in line with the 0, right? So basically we write here that y is an element of, and it goes from the lowest point, which is -2, to the highest point, which is 0, and close the brackets. Then what about the domain? Well, the most left part, to how far right does it go? It starts at 0 on our x-axis, that's why that dot is there, where the x is 0, and it goes all the way to the right, and it doesn't go further than 360, that's where it stops. So we can simply write here at the bottom that it will be x is an element of, and it starts at 0 and goes all the way to 360 degrees. And there it is, as easy as that. Okay, so how about our next function? We want to draw fx equals the sine of x minus 1. And to do that, I simply take my calculator again, and then I will just simply type in these values. And let's do this. So there we go, we press mode, and then we have fx, and then the sine of x, and we press alpha x, close the bracket, -1, and equal. We don't have gx, just press equal again. We start at 0, press equal, we end at 360, press equal, we work with steps of 90, equals, and there we go. So that is our coordinates. So 0 and -1, so x is 0, and where's the -1? It's down here. So let's just plot in that value. There it is. And how about the next one? We have 90 and 0. So at 90 degrees on our x-axis, we have 0 on our y. So it's right there. Let's plot that point in. There it is. And our next value is 180 and -1. There's 180. -1 is down here. And let's put that in. There it is. And then wait for the calculator to scroll down, and another one down, and another one down. There we go. And we end up with 270 and -2. There's 270, -2 is down here. So let's draw that in. That's that point there. And then we can see on the calculator that it is 360 and -1. There's 360, -1 is there. Let's put the dot in. There it is. And now I can simply put my calculator away. And there it is. And now I can simply draw my graph through these points. It's a positive sine function that moved one place down. A positive one from the point where we start always goes up, turns down, and go up again. So make sure about this sketch of yours. So it goes up, it turns, it goes down through that point. Keep going down, makes the turn again, and goes up and ends at 360. So that is how easy it is, and now we only have a couple of questions left. So what's the period of this graph? Well, it is a sine graph, so the period is always 360 degrees because it takes 360 degrees for an entire cycle to complete itself. What's the minimum value? Well, this is the lowest point. It's a -2. So let me write that in. There we go. What is our highest point? Well, it's right up there, which is also a 0. Similar to graphs this, but the one is just negative and the other one is just positive. And what is the amplitude? Well, we can read it there at the front. It is a 1, or another way to calculate it, we go from -2 all the way to 0, which is 2 units divided by 2 is 1. The range, well, it goes from -2 to 0. So this time we can write here that it is y is an element of -2 to 0. And the domain is x is an element of, it goes from 0 degrees all the way to 360 degrees. Now, It really doesn't matter what type of function they give you. You saw how it works on your calculator. You simply just plot the dots. Make sure whether the graph is negative, then you go down first. And if it is positive, you go up first. And you just simply go through those dots and make sure that you stay with the shape of a sine graph. In the next lesson, we will look at the cosine graph and we will see how that works as well. See you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.